bushes and bushes.
Vocab word is velocity. Velocity is speed and direction. So not just how fast an object's moving, but in what direction from the frame of reference. In this image, you can see the difference between speed and velocity. Both cars are moving at the same speed, but because they are in opposite directions, they are different velocities. If an object is not moving or remains at the same speed, it is going at what we call constant velocity. A change in velocity, that's a change in speed, direction, or both, is known as acceleration. If you change the speed or direction or both, the object is thus accelerating. In this image, we have a girl who is sitting still in a chair and is not moving or is going at constant velocity. There is an equal force, or push or pull, between her own weight pushing down on the chair and the chair pushing back on her. She has what we call balanced forces. Balanced forces would result in constant velocity and thus not accelerating. In this situation, when we speak about the fighter in blue, there is a force of friction acting on the ground, but the force of foot from the red fighter is greater than the force of friction. So we have unbalanced forces, or a net force, acting on the object. This would cause the object, in this case the blue fighter, to accelerate in the direction of the net force. Here we have a simulation in action. There are no outside forces acting on the girl, and since that indicates that the object has balanced forces acting on it, thus it is not accelerating or has a constant velocity. In this case, not moving, a constant velocity of 0 meters per second. Here she is moving at a constant velocity of 12.2 meters per second. Because she's at a constant velocity, I can assume that the forces acting on her are balanced. She is not accelerating, no change in velocity, thus no acceleration. Here I have a game of tug-of-war over this cart. Right now, there are some of the forces is 0, or the net force is 0. But if I start to add certain players for red and blue sides, so if I add a player here, now he's applying 50 newtons of force, and one on the red side. They are both applying 50 newtons of force to the left and to the right. We have balanced forces, and thus the cart remains at 0 newtons, and thus balanced forces and constant velocity. But now we can change this. Say we add another player on the red side. Now we are pulling with an unbalanced force, or a net force. This is going to cause the object to change its motion. In this case, you see an acceleration. Ottoman is at constant velocity and applying balanced forces. Here I can assume unbalanced forces because it's accelerating. Here my son applies the unbalanced force, causing me to accelerate backwards. Thanks, son.